So I've been looking into the topic of this video for a while, and I really wanted to introduce the concepts of angular resolution, visual acuity, and diffraction as they apply to the horizon, so that these laws of physics, light, resolution, and perspective can be taken into account and hopefully further developed in order to better understand our Earth, and also to help dispel some of the tired old myths of ships and buildings disappearing over the edge of a ball Earth. Now, mainstream science teaches us that the horizon is the edge of a ball Earth as it curves away from us, because ships disappear bottom first when they sail over this edge. What's funny to me is that their argument of ships going over a ball Earth is just as silly as falling off the edge of a flat Earth. It is a very childish argument, especially in today's world where we can pull objects back into view with a telescope or zoom camera, not to mention the fact that if you ascend in altitude, you can clearly see that a ship or building is not over the curve of a ball. It was simply out of your view due to perspective and the angles of light propagation when you're at a lower elevation. From a higher vantage point, your eyes can clearly see that the water or land is completely flat. There is no curve or edge that boats are sailing over. Again, it is a silly assertion, yet it is one of the main pillars of the ball Earth theory. In this video, I will introduce the concepts of angular resolution with a basic explanation, and then I will show another short clip of MIT professor Dr. Walter Lewin in his Physics 3 course, where he teaches these recognized laws of physics that we can test and observe. This is basically judo, where we are using their own scientific admissions to form a logical explanation of why we observe what we observe, and this in stark contrast to how groups such as NASA interpret the same observations. The survival of the ball Earth theory necessarily relies on NASA images and other space claims. Otherwise, their theory has only silly stories such as a spinning, orbiting ball Earth and non-existent curvature, or the direction of toilets flushing and boats going over the edge of a ball, none of which is observed by the average individual. So to begin, what is angular resolution? Angular resolution describes the ability of any image-forming device, such as a telescope, microscope, camera, or the human eye, to distinguish small details of an object. It is the minimum angle needed so that an instrument can discern resolvable detail, and it represents the resolving power and precision of optical instruments, which includes the eye. This angle is created at the eye or the lens, and it is based on the diameter of an object and that object's distance from the observer or the device. This angle determines the size of the image that is projected onto the retina. So once an angle is small enough that it reaches the angular resolution limit, no image can be resolved on the retina, and basically the object disappears. The formula to find the angular resolution of the human eye or any image-forming device is the constant of 1.22 times the wavelength of light divided by the diameter of the lens aperture or entrance pupil. Once you figure out the angular resolution of, say, the human eye, you can then determine how large or how far away an object must be for you to be able to resolve it. In other words, for you to be able to see it. This is the limit of eyesight, or the resolving power of a telescope, camera, or microscope. Anything beyond this limit cannot be seen. A shorter distance and larger diameter of an object equal a larger angle at your eye, thus easy to resolve. A longer distance and smaller diameter of an object equal a smaller angle, thus difficult for your eye to resolve. The size of the angle is also what gives us perspective. Objects do not physically shrink in size as they move away from us, but the angle in our eye gets smaller and smaller. which is what allows us to determine that it is moving further and further away. For objects coming toward us, the angle will get larger and the object will appear to be larger on the retina. This is an important part of perspective. This is how we distinguish objects moving away versus coming toward us. The angles also help us determine the size or distance of any given object. Visual acuity is another closely related term that means clarity of vision or the limit of one's eyesight, and it is a measurement of the angular resolution of the eye or the device. The generally accepted value for the angular resolution limit or visual acuity of the human eye is about 1 arc minute, which equals 0.02 degree. This means that at a distance of 1 kilometer, the human eye can resolve an object that is about 30 to 60 centimeters in diameter. Beyond this, the angle formed in the observer's eye gets smaller than 1 arc minute, and the object will blur and then finally disappear altogether. And here is another quick explanation of angular resolution by MIT professor Dr. Walter Lewin.
So in the remaining 5 minutes, I want to address the issue of the angular resolution of your own eye. You can now calculate what the ultimate angular resolution is of your own eye, because you can estimate what the diameter is of the pupil, the opening of your eye. 3 millimeters, maybe 5 millimeters, a little bit larger at night when it is dark. Pupil opens up, but we can calculate what this is. If I take 4 millimeters, so I put in for A 4 millimeters, and if I take lambda 5,000 angstroms, it's not an unreasonable value, then I find that the best angular resolution of a human eye is half an arc minute. Cannot be any better. There's just no way around it. You're always stuck with the diffraction limitation. I think, though, that most of you will not be able to see with an angular resolution of 1/2 arc minute. Most of you are probably in the domain of 1 arc minute. It's a little larger than diffraction limited, but it's very close to that. That is 30 arc seconds. That is 600 times worse than Hubble Space Telescope. When you think of diffraction, it's really an incredibly fascinating thing. Because what does diffraction actually means? That it is a limitation that is put upon us, on everyone, also God. No one can bypass diffraction. No matter how hard we try, we can never undo our chains and handcuffs that are imposed upon us by diffraction.
And he's definitely not a flat earther. He obviously believes in the Hubble telescope. The main reason I want to introduce these concepts is to demonstrate with logic that there are scientifically proven and verifiable factors that determine how far we can see with our own eyes and with telescopes. Angular resolution equations are used by NASA, astronomers, and scientists to determine the resolving power of the human eye, cameras, microscopes, and telescopes, including the Hubble Space Telescope. So when people say, if the Earth was flat, then we should be able to see Europe across the ocean,